attached to that is a mini computer, really. It's what we call a relay. It looks at the voltage and current that's on the line at that specific location, and then based off of what it's seeing and it's doing lots of calculations, we program it to make those decisions. And once it sees something that it believes it to be a fault, it'll send an open command to the circuit breaker and actually open it up and de-energize the line.
Hello and welcome to the Lewis County PUDcast, affectionately known as the PUDcast. Today with me, I have our engineering manager, Travis Kinney. And Travis, tell me a little bit about yourself. I mentioned your title already, but how long have you been here with the PUD?
Yeah, well, thanks for having me. So I started at the PUD back in 2012 as an intern, and I interned here for about 3 years until I graduated college in 2015 and started on full-time then. Been working in the engineering department since.
And did you grow up around this area? Are you a Lewis County native?
Not officially Lewis County, but I feel like I am because I grew up in Rochester, which is just north of the border. So, my whole life was spent in this area, going camping in Mayfield and Rifle Lake and that type of stuff. So I feel like I'm from here, but not technically.
I wanted to have you on today as I feel like a lot of people, when they hear about a PUD or what they know about a PUD is what they see on the outside. And I feel like that's mostly linemen or when their power's out, calling people to come out and fix it. But I don't feel like a lot of people really know what an engineering department does at a PUD. So that's kind of what I want to learn about here today. And hopefully somebody will listen and learn along with us about what an engineering department does for the PUD, because I feel like it's a huge role that you and your team play for our utility. So we will start with, what are some of the primary responsibilities that the engineering department here at Lewis County PUD, what's some of the primary things that you guys do?
Well, we in the engineering department, we have a wide range of roles and responsibilities, I guess. We have about 3 or 4 different groups that work in the engineering department. So we have our transmission distribution group. They are engineer techs. They're responsible for meeting customers on site and essentially figuring out how to get power to people's houses or businesses, then drafting up a job with a design on it, and then releasing it off to operations for them to go construct. And then, we have a T&D engineer that he primarily focuses on capital projects on the distribution and transmission system. And
is that what T&D stands for?
Yes. In large subdivisions, the developer will come in and want to build out the infrastructure for a subdivision. And so our T&D engineer will design that for the larger ones, the 3-phase subdivisions. And then our techs would pick up the individual customers as they come along. And then we have what we call system engineering in our department that is more geared towards the technical side of things. So they perform system impact studies, load flow studies. They work on our coordination, our protection of our system, large capital projects like substations and building out infrastructure that way. They do the studies and they figure out what needs to happen. And then some of the projects they'll take on and some of the projects they'll hand off to our T&D side for them to construct. We have a GIS department, graphical information systems. So it's essentially all our mapping. So they are the keepers of a lot of the data that we have, and they provide the data in the system so that way operations and other people can see what's out. It's essentially what is where, and so we can keep track of all of our assets.
And I think something that I've seen a lot of that I didn't really know was part of it is like if someone's building a new house, that part of your team is working on that. You mentioned that, I think, with the first group that you mentioned, but can you talk a little bit quickly about what the process is there? Like, what is that team doing to try and help that process get going for new construction?
Sure. Most of the time, a customer will inquire about getting power to their property or something, and then we direct them to put in an application. The application really gives us the kicks off their project with us and gives us a base information on what they're trying to do. And then depending on the geographic area of the county, we assign that job to one of our technicians. They all kind of have their own little areas, so they're not all driving across the county. But then after that, the tech will meet the customer on site and usually go through and line out what the customer's responsibilities are, like digging the ditch or whatever the case may be. And then what the PUD's responsibilities will be, they'll come back, they'll draft up the job, they'll do a cost estimate, and we'll send that off to the customer after the customer pays their estimate, and they'll do their portion of the job. And then when it's ready for our crews will go out and install the facilities and hook them up.
So a lot of the planning side of things and coordination. And then you talk about you have an whole other section of your group that's working around substations or major projects like that. Is that something that you guys have to constantly maintain and keep track of with substations? I feel like a lot of people are like, oh, there's a substation over there. It just kind of always works. Can you talk about that a little bit? What goes into some of the maintenance and upkeep of a substation?
Sure. Yeah, you're right. A substation just kind of sits there and people don't really pay much attention to it. It's an important piece of the puzzle. I mean, a substation essentially takes the transmission system at a high voltage that's able to go long distances, and it steps it down to a lower voltage in order to get out to customers' homes and businesses, essentially. There's really nothing too special about it other than having a lot of electrical equipment in a small condensed area. So we put a fence around it, secure it so people can't get hurt or anything else like that. You know, we typically think of substations lasting 50 years. So when we design a substation and build one, we're hoping to not have to go back to that substation and rebuild it within 50 years. But there's a lot of maintenance that goes along in that 50-year amount of time. So, you know, we have devices that just sit there a lot. So we have to exercise them like a switch or something. We might have someone go out there and just operate a switch just to make sure all the joints and connections work properly, clean. This part of the country, we get a lot of moss and everything else. So you get contaminants on our insulators, which can actually conduct electricity and track, and then we can have faults based off of it. So it seems like a minor thing, but cleaning the insulators is really important to us. Then there's electrical testing. So we have like our transformers or our circuit breakers, the electrical equipment inside the substation that we test on a regular basis. Not only test the oil inside the transformer, that gives us like a report of its health, kind of like getting your blood drawn at the hospital. You get a little report annually on that. We'll do electrical testing too, just to make sure everything's performing as expected.
When people see different substations around the county, is there like I don't know, this is kind of a random question that's popped into my head, but is there like a amount of power lines or area that you would like a certain substation to cover? Or is it purely based on the amount of homes, or is it kind of a mixture of both? When you're looking at, like, if you were building a new substation, how many customers around, or is it like a distance thing? How does that work?
Yes, it's all those things. Distance is a factor. You know, after you start pushing power on the power lines too far, your voltage lowers, and then we maintain voltage to customers. So that's something that it's kind of like your water company maintaining pressure to your house on your water. We're maintaining that voltage, so we're managing that. So distance can be one thing. The amount of demand or load on the system can do that too. Or just big developments like down in Winlock, the industrial park down there. They want to bring in larger loads and everything, so we have to build the infrastructure up for them. Ideally, you would have your substation be as close as possible to the load center. So that's why a lot of times you'll see ours in cities like Winlock, Mossy Rock, Packwood. We try to place them closer to where all the load's going to be. But then if development happens in a random spot of the county, then, you know, we might have to look at doing something and extending a substation onto that area as well.
What types of engineers work in your department? Like, what's the difference between a technician and you mentioned your transmission and distribution engineer? How do you get into those different fields?
Sure. So our system engineering team is traditionally an electrical engineer with a bachelor degree. And then on our transmission distribution side, our technicians, they typically have a 2-year degree, but a lot of their training comes on the job. And so they learn our specifications and the way that Lewis PUD does things. They learn a lot on the job. And then the T&D job really is just an extension of the techs. It's just someone that might have more experience, maybe a little bit more education, but primarily it's the experience and knowledge of building or doing projects with the PUD. So they're just a little bit more seasoned in that regard.
So if somebody wanted to get into one of those different things, there's a couple of different routes that someone could take.
Absolutely. Even on the system side, if someone was really interested, and let's say they were a tech for many years and they wanted a new challenge or something, we would take that experience that they had at the PUD into consideration. And then if there's a job opening or whatever the case may be, they could transition over to that side of things as well.
When you were going through your education process, was it electrical engineering then for you?
Yes. Yep.
Did you have utilities in mind, or was it more of a broader field for you when you were looking at the engineering field?
I used to work in construction construction before I went back to college. So I went to college as a little bit later in life. And Centralia College had a civil engineering technician type position, but they were spinning up a new program for power plant operators. And that seemed interesting to me, so I decided to get that degree. About halfway through that, my instructors really encouraged me to continue on for an engineering degree. So it was kind of a continuation on that. And about that same time is when I started the internship here at the PUD. So I got firsthand insight to what utilities do and everything else. And so that kind of sparked my interest here.
Looking back to the system, it seems like every utility has their different challenges that they face when it comes to maintaining the entire grid that they have. Ours come with its own specific challenges of being in the middle of a forest. Is that the main thing when it comes to your role in engineering? Do you look at the area that we're in? Are there any other specific things that you have to take into account when you're talking about our electrical system here at Lewis County?
Definitely the area and the terrain and geographic area we're in provides challenges. I mean, all utilities we all try to do the same things, but we have to do it differently based on these factors you just brought up. There's also the customers we have in the industry that's in our area that could be widely different. Down kind of the greater Winlock area, we have Cardinal glass manufacturing plants. So they have specific requirements, more so than a mill out in Morton or something. So it's really customer driven in that regard. And then, like I said, with load growth, subdivisions popping up wherever they can and everything else. So we have to take all those into consideration and then look at trying to improve our system to make it more reliable. Our goal is to sell power to customers, right? And keeping the lights on. I know we have outages, and like you said, we're in the middle of a forest and the system doesn't like tree branches. So, trying to figure out ways to improve the system to have more redundancy or maybe quicker restoration, or maybe putting some lines underground where we have really high troubled areas or something. So it's kind of all those factors all at once. We're just trying to manage that.
And you mentioned load growth. I feel like that's a topic that comes up a lot in the utility industry with people doing things more with electricity, electric vehicles, stuff like that. When you're looking at our area specifically, it seems like when I see you talk at commission meetings, you show a lot of new construction. And how do you plan for something like that with like a bunch of new load, new people moving into the area, as well as expecting electric vehicles, stuff like that? How does the engineering department need to I don't know if combat's the right word, but prepare for it, I guess?
It is definitely a challenge. The biggest challenge in that is that it can change quickly. Like I was talking about earlier, we plan for 50 years in advance. We have to do short-term and long-term studies all the time. And I'm trying to get us into a groove where we do our planning study for a 4-year plan and then revise that every 2 years, so we can give it time for our projects to actually get implemented for one, but also see that load coming. So, we might predict Packwood's going to have a lot of load growth, and then something happens and then that doesn't show up. Well, now we need to shift and put our resources towards somewhere else where the load actually is growing. So that can be challenging. Electric vehicles, it seems scary at first, because if everyone puts an electric vehicle in, or you have a party at your house and you have 5 electric cars charging all at once, that would totally do damage to our system. But I don't think it's going to be like that. I think people will inherently learn how to charge their cars and everything else. And you're going to see a lot of this happen towards the evening time or when the loads drop off. So we're going to see that load growth, but I don't think it's going to be instantaneous hit to our system like what a lot of people think about when they think about that happening. So we're going to see definitely low growth more than we've seen in the past due to it, but I think it's just going to be incremental over time.
Earlier, you mentioned when you guys are working with different projects and then you send it to operations. So most of the design happens in engineering, and then is it operations that then goes out and does all the construction side of things?
Pretty much. I mean, if we want to oversimplify it, engineering designs the system and operations constructs it. Again, that's an oversimplification. There's lots of nuances in there. But, we look at it, I try to look at it from a perspective of, we design, but we also are there for support. So maybe operations is constructing a job, but they see something that we didn't see, or they run into an issue that we couldn't tell, or, they just start digging a hole and they find something. Who's going to know that up front? So we're there to support that when those issues come up. And then also during outages, The system engineering group does a lot of support during major storms for restoration. What can this substation handle, the additional load we're going to switch onto it or not, or those types of things. While the engineer techs will go out and they'll try to scout out the outages ahead of the crews, so that way they can report back and say, hey, this is the material you need to restore power at this location or not, to help speed things up.
That's something interesting that I think I would like to learn more about is when you talked earlier about redundancy, like in an outage situation. Sometimes it seems there's a situation where, I'll talk to one of our dispatchers and he's telling me about an outage and there's so many people out of power. And then other times he'll tell me that and he'll be like, but we're going to switch some things around and they should be back on soon while we're doing the work. How does that work in a different situation? Is it a different substation that's being utilized? And is that something that we try and do as much as we can when we're talking about redundancy in our system?
I would say on the west end of the county, the greater Chehalis area, there's a lot more substations adjacent to each other. So we have tie points that we can close switches and open up other ones and refeed certain sections of our substations or distribution system. On the east end of the county, it's a little bit more challenging because it's a radial line out to Packwood, really. I mean, there's not a lot of looping around in that area. So we're challenged by the terrain out there. So it just depends on where the outage is and if we have the infrastructure available to do the switching around. And sometimes switching takes time. You have to drive to locations and everything. And sometimes the crew will show up and say, I'm just going to fix it real quick, because they feel that by the time they drive around and everything, they could have it fixed and be done with it. So it's really a game time decision and when they show up and how bad the outage is or whatever the case may be. In engineering, some of the things we look to is, can we put more infrastructure out, maybe more devices, and maybe automate some of this restoration or at least speed up the restoration process, so we can utilize those switches a little bit more quickly and everything else. So
it seems like there's a lot of new things coming when it comes to engineering with different automation things. Is that something that you can talk about a little bit, like some of the new tools that you guys have when it comes to the reliability, but also getting the power back on and getting that information of like where the power's out and that type of stuff?
For sure. We started implementing a couple of different technologies that help us with that. AMI is one of them that once it's up and fully functioning, right now we're still in the deployment stage and trying to optimize the system to get the communication network up. But long term, once that's up and fully functional, we should be able to get outage notifications relatively quickly and be able to know when the power's out, or just issues with people's services. I mean, we've had a couple where we've gotten an alert through the AMI system and I sent it to operations and they went out and looked and they had a failing meter. So we were able to catch that before it actually failed. And before, in the past, we would wait for a meter reader to show up and look at a meter and say, oh, this meter failed. And then we would have lost that information. So we can be a little bit more proactive in that regard. Another thing we have been deploying, and it's still a work in progress just because it takes so long to deploy all the equipment, is SCADA, which stands for Supervisory Control and Data Acquisition. It essentially gives us visibility and control of our system, specifically at substations, but also some field devices. Once we get that fully deployed, that's where we can actually automate some of these things or give control to like our dispatchers over certain things. So they can either manually or automatically restore part of the power before we even have linemen show up.
That acronym, SCADA, part of it's data acquisition. And that's a lot of like what's going on with the power lines. And can it help you locate where issues are like along the distribution system?
It's really just taking stuff and reporting back to a central location. Dispatch, engineering has insight into it also, but dispatch is really the users of that. So it will report information back and then we can see status and conditions like that. And when we start talking about faults or anything else on that, it's actually the equipment in the field that will do that because we're talking milliseconds. It's really quick to a human. Electrical world, it's really slow, but to a human, it's really quick. But the SCADA, like the data acquisition part of it, that's still relatively slow. If we get response back within a couple seconds, that'd be too late for us to open up a fault, ideally. So the protective devices out in the field do that monitoring of it, and they're programmed essentially to make decisions and everything else. And then it can report back its status on what it did and why it did it, essentially.
And those devices, can you talk about what a couple of those are that are programmed to do that and make those quick decisions?
Yeah, so we have protective devices like a circuit breaker or what we call a recloser, which is essentially a circuit breaker that's just not inside a substation. And then attached to that is a mini computer, really. It's what we call a relay. It looks at the voltage and current that's on the line at that specific location. And then based off of what it's seeing and it's doing lots of calculations, we program it to make those decisions. And once it sees something that it believes it to be a fault, it'll send an open command to the circuit breaker and actually open it up and de-energize the line.
Oh, that's fascinating. So like if there was a tree in the line or something like that, it would de-energize it to prevent any further damage from happening?
Yeah. And well, two things. One, protective devices are to de-energize the system when there's a fault. It's not to protect human life. So if a lineman's working on it, that protective device isn't going to protect that lineman. So they have to take their own precautions and safety into consideration there. Although we are trying to always improve, and it's part of the industry is and the research that goes on is how to make those relays smarter and be able to see things that we haven't seen in the past. The manufacturer we buy relays from, they're really trying to get it to the point where it can detect a broken line and de-energize before the line hits the ground. Ideally, prevent forest fires or whatever the case may be, or public safety.
Because right now, if you see a line on the ground, treat it like it's live.
Absolutely. Because it could be.
Yeah.
You never know. Faults are hard to, it's kind of an art and science at the same time. We try to do our best to capture every single fault that's out there, but there's some that happen and the device just, it looks like someone turned on a lot of load at once and it doesn't actually look like a fault to that relay. So it sits there and it doesn't open up. And then that's when you have wires on the ground.
I had some questions outlined for you and we've just like completely gone way past those, but this is super interesting to me. So I love hearing and learning just a little bit about this. When there is a line on the ground, and because public safety is such a huge part of what we do, you know, let's say there's a situation where like there's a car versus pole accident, there's a line on the ground. I put out information, you know, stay in your car if possible. But if your car's on fire, they say to try and hop out on 2 feet and do a weird shuffle thing. Can you talk a little bit about A, the purpose of staying in your car, and then B, if you absolutely have to get out, what's going on in that situation to try and get away from the downed line?
Yeah. Stay in your car. For one, your car has rubber tires on it, so you're somewhat protected from it. You're not fully protected, so it's best if you can just sit there and try not to touch anything, especially metal, but there is some protection there. Where people can get hurt is getting out of the car and then touching the line. So that's a bigger issue, really. So stay in your car so you're not getting contacted with the live wire. Again, if you have to, you get out. And yes, the hop and shuffle method is widely advertised, I guess. And that's due to when there's a fault or a line on the ground, it's essentially pumping a lot of energy into the ground. And what can happen is that the ground itself can have a voltage, it's called a voltage gradient. So it can change the voltage on the ground. You're not at 0 volts anymore. But even if you're not at 0 volts, you want to be at the same voltage. You don't want a difference in voltage because that's when current will flow. So by taking a step and it has a voltage gradient on the ground, you could have a voltage difference between each of your feet. And then when that happens, then you can get current to flow through your body, essentially. It takes milliamps. It takes very little actual amperage to harm or kill someone. Because I do electrical safety training for people that enter substations. And I think on one of the slides, I think you can physically feel the electric and how your muscles contract and everything with less than what it takes for an electric toothbrush to operate.
Whoa.
So it's very little. So that's the goal, is keep your feet close together so you don't get that voltage difference.
Gotcha. And then another question that popped into my head is, you know, just kind of the buzzwords or headlines that you see around is I see the term microgrids. Is that something that can help with redundancy, or what is a microgrid and why are they good? And is it something that we would look to helping our system?
For sure. I think there's a place for microgrids. I guess, first of all, microgrid is having generation like solar on people's houses or a battery or some other source of electricity out away from the substation or even at a substation. If you have an outage and you can disconnect that portion of the system and it has its own generation and can supply power to it, becomes a microgrid. So like I was talking about radial feed out to Packwood. If Packwood goes down, we have Packwood Hydro actually is out there and can generate and supply Packwood or even up to Randall. Technically, when they separate from us, they're a microgrid because they're not connected into the greater grid. So we've been doing microgrid for a long time. It's just we didn't call it that back then.
Okay. Good to know. Gotcha.
Traditionally now with the buzzword microgrid, they're talking about solar solar or batteries or something else. But yeah, we could look at out in LB or in Ashford, there's lots of outages out there. That's right up butts the national forest. And, that could be a good spot to help supply power to during outages or major outages.
You mentioned solar or batteries. Also, another thing that we've talked about in the past is when people have generators on their houses and how that is set up. And we would need to know about it in like an outage situation so it doesn't backfeed a line that maybe our guys are working on and then causing some danger issues there. Can you talk about what people would need to do in that situation if they do have a generator that's hooked up and how to do that safely and not impact our guys working to try and restore power?
So generator, a lot of people do that on their system, and there's different like interconnect devices on their breaker panel where they'll have to shut off their main panel in order to turn on the breaker panel for their generator. So it's a physical lockout, so it doesn't allow the generator to be on while they're connected to our system. When a customer does that, that's part of L&I's inspection when they put that system in and everything else. So we're relatively protected from that unless someone just goes rogue. But they could go rogue regardless.
Yeah, don't go rogue. Don't go rogue with electricity. It gets dangerous.
With solar, though, when solar first came out, it was a big topic, and now utilities are pretty comfortable with it, mainly because people were just putting in systems willy-nilly back in the day. Now, all the devices on, like all the inverters and everything, they have a safety feature in them, and that's part of the application process. Engineering looks to make sure they have it's called IEEE 1547 or UL 1741 certification on their device. And that essentially guarantees that it's been through a lot of testing and that it will have a rapid shutdown feature. So if it loses connection to our system, it will shut down their system so it doesn't backfeed. If a customer puts batteries in, then their inverter has to take that into consideration and it'll disconnect from us, but it'll supply power to their house off their batteries. There's safety features embedded into that.
It's just another thing led to another question because solar is such a huge topic too. How does our utility handle people putting solar on their houses? How does that work to benefit our customers if they want to go that route?
Yeah, so it's mainly a benefit to the customer for sure. It does lower our load, but we still try to account for that if their solar wasn't working, because that's the last thing I want to do is rely on someone else's generation, not be able to supply power to people. So it's really a function benefit for the customer, but our energy services team, they take in the application from a customer, and all the solar installers know our process, so it's pretty common. They'll submit an application that gives us all the information, a drawing of what they're planning on doing, has the data sheets so we can verify their equipment, and all that gets sent up to engineering. Engineering does a quick review, and then we send it back to energy services, and energy services contacts the customer. Then once they paid their application fee and we reviewed it, customer goes and builds their system, usually has an electrician or someone build it for them. And then afterwards, before AMI, we would have to go physically swap out the meter. Our meter shop would go physically swap out the meter. Now with AMI, it's more of a program change in NISC. Well, I guess, and in the meter. So we send a program change to it, and then it does the calculations for us then.
So it keeps track then of what's generated and what's used?
Somewhat.
Okay.
So we don't look at what's generated, because whatever a customer generates, that power will go supply their own load at their house. Anything extra will get pushed back onto our system, and that's what we'll keep track of.
Interesting.
And
so
then
only if they generate enough to power their house and then have extra.
Correct.
Okay.
Or everyone's gone from the house during the day because they're at work and it's a summer day. They'll probably push a lot of their generation onto our system during the day. Then at night when they get home and the sun goes down, they'll pull off of our system.
Okay.
And so it keeps track of both of those, and then it's just a calculation, one number minus another, and then that's what they get billed for.
Well, I can't think of any more questions that have popped up. Thank you for just fielding the random popcorn questions that I threw at you.
Hey, it's a pleasure.
It's a lot of fun. Learned a lot. Maybe I'll just come up and ask you more questions by myself sometime to learn more, but I really enjoy learning more about the electrical and especially our system.
Perfect. Yeah. Well, thanks for having me.